Let's continue working on the code from last time. It was set up like this, and if you remember from last time, we just read 1 byte and displayed it in hexadecimal format. In this section, we are going to initiate the data collection process. To properly analyze and interpret the collected data, we will be utilizing a buffer. This buffer will help in managing the data efficiently and ensure that the parsing is done correctly. Assuming the buffer is 256 bytes for now, let's delve into what this means. A buffer, in this context, is a temporary storage area typically used to hold data while it is being transferred from one place to another. The size of 256 bytes indicates the capacity of this storage area. Additionally, I have introduced a variable named ID's buffer. This variable is crucial as it specifies the exact position within the buffer where data needs to be placed. This helps in managing and organizing the data efficiently. Now let's explore this concept further using a switch statement. A switch statement is a control flow statement that allows a variable to be tested for equality against a list of values, each with its own case. For instance, if the case is 0, then the corresponding block of code will be executed. This is particularly useful in scenarios where multiple conditions need to be checked. To illustrate, consider a situation where we need to handle different types of data based on their identifiers. By using a switch statement, we can easily direct the flow of the program to the appropriate handling mechanism for each type of data. This not only simplifies the code, but also makes it more readable and maintainable. So, in our example, if the case is 0, the program will execute the specific instructions associated with this case, ensuring that the data is processed correctly. First, you need to check if the first byte of the data matches the start of text STX character. This is a crucial step because if the first byte does not match the STX, you should immediately exit the process to avoid any errors. However, if the first byte does match the STX, you can proceed to the next step. In this case, you will add the byte to the IDS buffer. It's important to note that when we refer to the IDS buffer, we are simply talking about a buffer where we store the IDs. For simplicity, we can just call it the buffer. After adding the byte to the buffer, the next step is to insert the character B into the IDS buffer. This is a specific requirement of the process. Once B is inserted, you can then move on to the next part of the process, which involves handling the length len of the data. This step is crucial for ensuring that the data is processed correctly and efficiently. Next is the length, which is followed by the command. After the command, it could be either data or a checksum. Up to this point, it is considered case 1 for the command. For case 2, it is the length. Insert the command and then break. Next is the length followed by the command, and then it could be either data or checksum. Up to this point, it is case 1 for the command, and for case 2, it is len. Insert the CMD and then break. Then, let's proceed to the next step. In our process, ensuring that we carefully follow each instruction and pay attention to every detail to achieve the desired outcome. Since the length cannot be 0, let's check the maximum. Length, which is crucial for the proper functioning of the system, and is essential for the system's stability and performance. Even if there is no data available, the command should still be written as originally intended to ensure consistency, reliability, and accuracy. In ETS, there are 4 items, but there should be at least 3 or more to meet the minimum requirements and ensure proper operation and functionality. In situations where the value is less than 3, it is important to carefully consider all the potential consequences and implications that may arise from this condition. Since this has an error, we need to rewrite it. We should set it to restart. We'll do it this way. First, identify the error. Then rewrite the section to correct it. After that, we need to ensure it restarts properly. Here, we can check the command to verify everything is correct. However, I will skip the command check and input it directly. This approach ensures that we address the error, rewrite the necessary parts, and restart the process without unnecessary delays. By skipping the command check, we save time but must be cautious to avoid further errors.
So, as you can see, we create the first buffer, and insert 1 byte at a time. If the current IDX buffer is 0, and the incoming byte is not SX for the first buffer, then we simply exit the switch statement. If it is correct, we insert it and increment it to 1. Then, when the next byte comes in, we said that the IDS buffer is 1. But if the incoming data corresponding to the range is less than 3, because now the maximum of that data must have a range of 3 or more, but if it is less than 3, then that is incorrect. In that case, we should initialize the ID's buffer to 0, and then break out of the switch statement. If it is not the case, we will store the range here, and then the ID's buffer will be incremented to 2. When it becomes 2, we proceed here. But if someone wants to check more at the initial stage, they can do it this way. It might get a bit complicated, so we should use switch statements. And if statements, then since it's not C, there is also a protocol issue here, so we can initialize the buffer to 0 and exit like this. It might get somewhat complicated, but you can handle it this way. After that, you set it up, and then after CMD it will be data or checksum, right? So if we exit with a default state that is not 0, 1, or 2, it would be better to add a variable to handle this specific case. By the way, the code here is only needed over there in that particular section of the program, so this way the sender side won't compile at all if we don't make this change. Changing it like this ensures that the code functions correctly, and then here, when it comes to the range part, we do B once like this to ensure proper execution. Of course, we could do it this way too, but for now, I've added a variable to make it clearer and more maintainable. This approach helps in debugging and future modifications. Additionally, it's important to note that handling different states properly can prevent potential errors and improve the overall robustness of the code. By adding a variable, we make the code more readable and easier to understand for anyone who might work on it in the future. This change is crucial for maintaining the integrity of the program and ensuring that it runs smoothly without unexpected issues. In this particular scenario, the buffer will most certainly be utilized at a later stage. Consequently, the command prompt, often referred to as CMD, will naturally make its appearance. At this point in the process, then SDX will come in at that particular point in time. In the next step, if the IDX buffer variable is present and properly initialized, then proceed accordingly. Eisen's buffer should not have a 0 length data length let's call it a real length. The real length is the real length. The real length is essentially the actual length of the data in the buffer. This means that the buffer must contain some data and it cannot be empty. The real length is crucial because it determines how much data is stored and processed. Ensuring that the real length is not zero is important for the proper functioning of the buffer. Originally, what was missing here is the STX. In reality, it's the STX plus the ln, which gives us the total length. Initially, that was completely missing from the equation. However, in the current scenario, it is not just the STX, but also the ln, which together provide us with the total length. The total length of the final result will be the random number. That is generated, to which we will add 2. This means the final length is the sum of the random number and 2. If the IDX buffer has an issue, then it is now ready for further processing. The IDX buffer, which stands for index buffer, is a crucial component in the system. It is responsible for storing index data that is used for quick access and retrieval. When the IDX buffer encounters an issue, it means that there might be a problem with the data integrity or the way the data is being accessed. However, if the BTX is not correct, then there is a problem that needs to be addressed immediately. The BTX, which stands for buffer transfer, is another important component. If the BTX is not correct, it indicates that there might be an error in the data transfer process. This could lead to data corruption or loss. Therefore, it is essential to ensure that both the IDX buffer and the BTX are functioning correctly. Here, it is now ready for parsing. And as you can see, the buffer has been created successfully. Parsing is the process of analyzing the data and converting it into a format that can be easily understood and processed by the system. Once these components are verified and ready, the system can proceed with parsing the data. As you can see, the buffer has been created, and the system is now ready to move on to the next step in the process. Next, I covered a variable that can determine the position of the buffer and divided it into a variable that stores the length of the part behind the range based on the range. So when the IDX buffer is 0, it starts at 0. When it is 0, check if the STX has been received correctly. If not, break out and use the last IDX buffer 0 to insert the STX at the beginning. Then the IDS buffer is added, and in the second instance, a random value comes in. This random value cannot be less than 3 according to our protocol. If it is less than 3, there is a problem. So we need to start stacking the packet buffer from the beginning, using the IDS buffer to break out. If it is not the IDS buffer, and is 3 or more, then it is a normal case, and we will consider it based on the IDS buffer for the second instance. When the second one is added, 1 is now added to Eisen's buffer. After that, the same byte value is also inserted into the real rank. Next, a command comes in, and this has been set up to show you that it can be done in this way. So, if the command is neither A, B, nor C, then that is also a problem. Then, the IDX buffer is reset to start from 0 again. If not, it continues to accumulate. After that, other elements may include incoming data or checksum, and now the ETX can also be received. At that time, I kept adding until the IDS buffer reached real X plus E, which means that the back part plus 2 is the total length. At the point where the total length exceeds this, we can now check if the ETX is coming in correctly. If this byte is not the ETX, then there is a problem. So we reset the Eisen's buffer to 0. If there are no issues, then we proceed with the parsing, at which point MBC news. Let's not do this. After buying, then check the rank data with the packet. If it's packet check, rank data, then it's real rank plus 2, the total length. Then we will use the buffer to check. If this specific condition is not the case, it will break out like this particular scenario, and it must always initialize the id buffer to 0 to ensure proper functionality. Additionally, I have set up a comprehensive fact check mechanism here, and in the case of failure, which means the conditions are not met, it will break out instead of in the case of success, where everything works as expected. This ensures that the system operates smoothly, and any discrepancies are handled appropriately. Then, if it's exactly and precisely correct, I'll just randomly cut it to ensure complete and absolute accuracy, as I did in the previous instance. After identifying the hot data rank, the next step is to execute the command car command package get cmd to display the data in an Excel spreadsheet. This command is essential for visualizing the data in a structured format, which can be very helpful for further analysis. Excel is a powerful tool that allows you to manipulate and analyze data in various ways, making it easier to identify patterns and trends. Once you have the data in Excel, you can proceed to the next step, which involves further processing and analysis of the data. For the get data command, it is important to note that you should ignore the memory and other related aspects for the time being. This is because focusing on these details at this stage can complicate the process unnecessarily and divert your attention from the main task. By ignoring these aspects, you can streamline the process and focus on the most critical elements of the data. If you encounter data that is unknown or not immediately recognizable, we will refer to it as eolive. This is a placeholder term that helps us manage unidentified data points and ensures that we can keep track of all data, even if it is not fully understood at the moment. For instance, if we do not know the length of a particular data set, we should check the source length destination. This step ensures that we have a clear understanding of the data flow and can identify any discrepancies or issues that may arise. By checking the source length destination, we can verify the integrity of the data and ensure that it is accurate and reliable. Instead of using the term 0i plus data rank, we will use data rank for simplicity and clarity. This change in terminology helps avoid confusion and makes the process more straightforward. Using clear and concise terms is essential for effective communication and ensures that everyone involved in the process understands the instructions. Finally, you will need to call the function cr.buildData with the appropriate parameters. This function is crucial for building the data structure required for further processing. Here is an example of how to call this function: cr.buildData parameters. By following these steps carefully, you can ensure that the data is processed correctly and efficiently. Remember, each step is important for achieving accurate results, so take your time to understand and execute each command properly. Additionally, it is always a good idea to double-check your work and verify that each step has been completed correctly. This attention to detail will help you avoid errors and ensure that the final results are accurate and reliable. So, I will try compiling it now in this state.
There is no split error, and it's set up in this state. So, if the length of the IDX buffer exceeds the total length, it no longer makes sense to receive more data. So, the IDX buffer must be initialized,
Then we check if the last received byte is ETX. If not, we break out. If the packet check fails, we break out again. If it passes, we proceed to data rank, which is marked based on what we obtained here, and the command is retrieved using getCMD, displaying the command in hex. Next, I assumed that the data could be of an unknown number of bytes, so I created an array variable to receive the data and set it up to display in hex. Now, I will execute this to ensure it breaks lines properly. I've uploaded it, and now, if you turn it on, you can see that the left side has succeeded. So the data rank is 1, command 0, data CA7D. Just a moment. It seems that the hex is outputting without any sound. But just a moment. The data rank is 1. Again, once more. Check. Let's see. Oh, I didn't remove this. If I remove it and save, it will upload neatly. And it will be the same as what was connected last time. The Arduino is sending the same packet from one side, and on the other side, it's receiving this through the buffer. Since parsing was successful, the data rank is 1, the command is 0, and the data is displayed as CA. You can add a switch statement here based on the situation, where the command could be LED or motor, and depending on whether the data is 0 or 1, you can add conditional statements. I will explain that again later with an example. This time, continuing from last time, I added code to the receiving side to stack this in the buffer, and when it's ready, I added a part to parse and check the data again. In the next session, I will demonstrate how to write the code based on whether the command is A, B, LED, or motor. Then, I will see you next.